On our website, you can download the PDF file that contains questions you should ask students before going into the Starlab. We'll confirm answers once we're in the lab. This is the seasons simulations. Let's see how to get there from the initial Starry Night screen and change a few options before we start asking students questions. Go to the Favorites menu. From there, choose Simulations, then choose Earth, Moon, and Sun. Choose Seasons, and then one last time, choose Seasons. Hide the Sky Guide window and the Search window. Let's double-click to maximize the window. It's helpful to see latitude and longitude. Poke the top to get your menus, then go to Options. Come down to Solar System, then over and down to Planets and Moons. In the Surface Guide section, we want to turn on all of the options. To better see the sunlight and the lines, we'll change our Earth view. Right-click on the Earth. Then find Surface Image Model, and from that menu choose Natural Earth.
Most of the images we have seen in Starlab have used models that kept the relative size and distance of celestial objects proportional. However, this model does not do that. What things in this model are not to the correct scale? The Earth in this model is extremely large compared to both the Sun and its orbit around the Sun. When comparing how wide they are, you could fit about 109 Earths across the center of the Sun. But you would need over 23,500 Earths to reach across the orbit it takes around the Sun. In case you forgot, we use the term diameter to describe how wide a circle is. The gravity of the Sun keeps the Earth in this orbit. What other important things do we get from the Sun? What position in the sky gives us the most warmth from the Sun? How long does it take the Earth to complete one trip around the Sun? If we have a leap year every 4 years, how long is each year? Is the Earth's path around the Sun a perfect circle? The path is not a perfect circle. Instead, it is elliptical. How far is the Earth from the Sun? On average, it's 149.6 kilometers, or 92.96 million miles. This distance is called 1 AU, or astronomical unit. The distance varies about 3% during the year. The term perihelion is used for when it's closest and aphelion for when it's farthest. I'll give you a handout once we get out of the Starlab. How many seasons do we have? What do we call them? What do we call the first day of each season? Summer and winter solstice, spring and autumn equinox. The last part of those names are from Latin. We'll expand on that later. Do the seasons start on the same day and time each year? Why? Because the number of days in the calendar and the exact length of a year don't match. The approximate starting dates for the seasons are December 21, March 20, June 21, and September 22. Why are the seasons important to us? Agriculture and the rise of civilization drives much animal behavior, keeps the ecosystems balanced, extremely important to weather patterns, social and religious celebrations. Early man used days, full moons, and the seasons as the early ways to measure time. What causes the seasons? What do we call the imaginary line that divides the top half of the Earth from the bottom half? Is that a line of latitude or longitude? What names do we give to the top and bottom halves of the Earth? What do we call the places at the very top and bottom of the Earth? Between the equator and the North Pole, we see 2 other latitudes that have names. What are they called? What are the 2 named latitudes in the southern hemisphere? What do we call the imaginary line drawn through the center of the Earth, from one pole to the other. The Earth isn't straight up and down, it tilts on its axis to one side. Why is it tilted? The theory that science uses is that it was knocked to the side by collisions with other large bodies during the formation of the solar system. How much is the Earth tilted on its axis? What does 23.5 degrees mean?
Use the laser pointer to show an example of a 90-degree angle.
If it was straight up and down, it would be 90 degrees. So it is tilted 23.44 degrees more than the 90 degrees. Look at the date. Think about the date as you answer the next questions. Is one hemisphere getting more sunlight than the other? On average, which hemisphere would have the warmest temperatures? What season is it in the southern hemisphere? What season is it in the northern hemisphere? As the Earth spins around on its axis during the day, where would you have to stand on this date for the sun to pass directly over your head? What do we call that parallel? Look at how much sun the South Pole is getting. Will the sun set there today? Put on your warm clothes. It's probably negative 22 degrees with a wind chill of negative 60 degrees, but I want you to stand on the South Pole. Any direction you face is north. But position yourself so that you can raise your right arm out to your side and point up to the sun. Hold your left arm out to the other side at the same angle. Now don't move. 12 hours later, what would you notice? What about after another 12 hours? What was the path the sun took through the sky during the 24-hour period? I'll take my pointer and draw a line from the sun down to the point on the Earth where the South Pole would be if the Earth wasn't tilted. Did the sun set anywhere within the Antarctic Circle today? What is the significance of the Tropic of Capricorn and the Antarctic Circle? On this same day, how much sun did someone standing on the North Pole get? In fact, the sun didn't rise above the horizon anywhere in the Arctic Circle today. I've asked you what causes the seasons. Here's a spoiler alert. On this date, the Earth is only a little more than a couple of weeks from being at perihelion. It's winter in Louisiana, but the Earth and Sun are almost at their closest. So does distance from the Sun cause seasons. But what if you lived in Sydney, Australia, and it was 112 degrees on this date? Would you be inclined to believe that distance wasn't important? Let's go around the Earth's orbit and see if we learn more. When you look down on our solar system, the planets are orbiting in a counterclockwise direction. Trivia time. All of the planets rotate on their axis in a counterclockwise direction except one, Venus. It rotates on its axis in a clockwise direction. At first, we'll jump around Earth's orbit a month at a time. Our first stop is March. Here we are at spring for the Northern Hemisphere, probably the most celebrated of all the seasons, but our model is showing the dark side of the Earth. What season is it in the Southern Hemisphere? Let's guess what we would see on the other side. How much darkness and light at the poles as the Earth goes through its 24-hour day? Which hemisphere is getting the most darkness today? Which is getting the most sunlight? How far down between the poles do you think you have to go to find the sun directly over your head? In each hemisphere, what is happening to plants and those animals that migrate or hibernate as we moved from December to March? The Earth is about 1 AU from the sun. Now let's move to June 21. Which hemisphere is getting the most sunlight today? Which is getting the most darkness? How much darkness and light at the poles as the Earth goes through its 24-hour day? How far down between the poles do you think you have to go to find the sun directly over your head? The Earth is about 2 weeks away from aphelion. We could now go to the North Pole and do the same experiment we did 6 months ago at the South Pole to track the path of the sun on this day. But there is no permanent land mass at the North Pole. Instead, you are standing on an extremely large plate of floating ice. But the same thing would happen as we trace the path of the sun throughout the day. Now we are going to slow it down and step day by day to September 22. Note the movement of the sun relative to the equator, especially once the sun's image overlays on top of the Earth. Which hemisphere is getting the most darkness today? Which hemisphere is getting the most sunlight? What about sunlight at the poles? How far down between the poles do you think you have to go to find the sun directly over your head? What is happening to plants and migrating or hibernating animals in each hemisphere as we moved from the last season to this one? The Earth is slightly above 1 AU from the sun. This is the autumn equinox for the northern hemisphere and the spring equinox for the southern hemisphere. EQUI is a Latin prefix meaning equal. NOX means night. On the equinox, there is almost the same amount of day and night. The Latin word that the term solstice comes from means to stand still. That's because the sun stops its relative movement of down or up at the tropic latitudes before heading back towards the equator. On the equinox, if the axis was straight up and down instead of being tilted, would that change the amount of sunlight reaching the two hemispheres? If every day of the year was like an equinox, meaning that the amount of light reaching the hemispheres is about equal, would we have seasons? So what causes the seasons?